Welcome to a second example of using the properties of perpendicular transversals of parallel lines to determine the measure of angles. Here's our diagram, and we want to determine the measure of angles 1 through 8. Notice we have two sets of parallel lines, and here we have a perpendicular transversal. So we know if we have a perpendicular transversal, 8 right angles are formed. So this tells us that the measure of angle 4 must be 90 degrees, as well as the measure of angle 1. And we also know that the measure of angle 2 plus the measure of angle 56 must equal 90 degrees, so that leaves 34 degrees for angle 2. And notice that angle 2 and angle 8 are corresponding angles using these slanted parallel lines, and therefore they're congruent or have the same measure. So angle 8 would also be 34 degrees. And then notice that this angle here marked 56 degrees and angle 3 are corresponding angles, therefore they're congruent. So angle 3 measures 56 degrees. Now let's take a look at angles 5, 6, and 7. Looking at the horizontal parallel lines, this angle here that measures 56 degrees is an alternate interior angle with angle 5, which means they're congruent, so the measure of angle 5 would be 56 degrees. Notice angle 5 and angle 7 form a linear pair, which means they're supplementary. So if angle 5 is 56 degrees, 180 degrees minus 56 degrees would give us the measure of angle 7. So that'll be 124 degrees for angle 7. And then notice that angle 6 and angle 7 are alternate exterior angles using these slanted parallel lines, and therefore they're congruent. So the measure of angle 7 was 124 degrees. Therefore that's the measure of angle 6 as well. And now we have the measure of each angle. So that's going to do it for this video. Thank you for watching.